Thank you for viewing this video about trig functions and how we can use their ratios to find missing sides of triangles. Here we're not even going to worry about finding the angle. So if you look at the original definition that was given to you, you have cosine of theta equals 7/9. We don't have to worry about finding theta, but what we do need to do is designate one of the two non-right angles of this triangle as being theta. Doesn't really matter which one. And I'm going to go ahead and say, let's make it this one down here. And by the way, that of course, that would be the right angle there. So if this is theta and we're dealing with cosine, the definition for cosine is adjacent over hypotenuse. That means that 7 is right here, 9 is right there. So how do we find sine of theta? That's my first question there. Well, the first thing we need to do is find this missing side right here. Well, this is a right triangle, so we can do 9 squared equals 7 squared plus that unknown quantity right there, which is our opposite side. So we can go ahead and call it b for right now, b squared. So we end up with 81 minus 49 equals b squared. And when we solve for b, we find that b is the square root of 32. All right, now we can reduce that a little bit, but we can leave it as 32 for right now. If you need more information about the algebra down there, well, we might need to go find a video about just doing that algebra portion, because what we're focusing on right now is just the trig part. Now, the definition for sine is opposite over hypotenuse. So I'd be doing the square root of 32 over 9. Well, we can, but we'd rather reduce that 32 a little bit if we could. And 32 is 2 times 16, right? So this would be the square root of 16 times 2 over 9. I'm going to get a little messy here. I'm going to come back down here to finish this. Square root of 16 is 4 on the square root of 2 all over 9. And that's what sine is equal to. If we want to do tangent, we do the same idea. The permanent cotangent here, and that is a reciprocal trig function. That's 1 over tangent. Tangent is defined as being opposite over adjacent. So here, cotangent would be adjacent over opposite. So here we'd be doing 7 over the square root of 32. We need to rationalize that. We don't want that root in the denominator. So we do the square root of 32 times 7, the square root of 32 times the square root of 32. A little bit of space so I can finish this one up. So it gives us 7 times the square root of 32 over 32. And then we can reduce that 32 a little bit, make that 4 square root of 2 like we did earlier. So it becomes, get a little bit more space here. So it becomes 7 times 4 on the root of 2 over 32. I can cancel that 4 with that 32, leaving me with an 8 in the denominator. And then I have 7 on the root of 2 over 8. All right. Here's another example. This one's a little bit quicker and easier. There's going to be less, fewer calculations involved in this because cosine is adjacent over hypotenuse, right? And I'm making this theta again. Well, Pythagorean triplet is 5, 12, 13. So I don't even have to do a whole lot of work. I just automatically know that's 12 there. So cosecant, which is 1 over sine, is going to be hypotenuse over opposite. And we're done with that one. And then cotangent, well, cotangent is going to be the reciprocal tangent. Tangent is opposite over adjacent, so this is going to be adjacent over opposite. Simple enough, right? Again, if you have any questions, feel free to leave comments in the comment section below, and I'll try my best to answer those. Thank you.